Myself, Dr.B.Krishnaveni, Assistant Professor, Department of Mathematics, Aditya University. Introduction to Linear Algebra. Now, in this lecture, that is in today's lecture, we are going to discuss about rank of a matrix and finding the rank of a matrix using echelon form. First, let's see the definition of rank of a matrix. If you consider any matrix A, which is of order m by n, and let us take R be any positive integer, that is R greater than or equal to 0, such that there exists at least one non-zero minor of order R and all orders of higher orders vanish. So, then we say that R will be the rank of a matrix. So, that is, if you take any matrix A satisfying these conditions, that is a positive integer R such that we are getting this condition, that is, if you are getting at least one non-zero minor of order R and the second one is all minors of order R vanishes, then we say that R will be the rank of a matrix. So, you can see here the symbolic form how to denote rank of a matrix, that is row of A. So, you can write the rank of the matrix either with rank of A or else row of A. So, now you can see what are the properties of rank of a matrix. So, if you consider any matrix, definitely it will consist a rank. So, that is what the first property we call as every matrix will have a rank and it must be unique. So, that gives the second property, the rank of a matrix is unique. And the next one is, if we consider any matrix of order m by n, so which we call it as rectangular matrix or square matrix or anything, in general we call the matrix having the rank, order m by n. For that, what is the rank is? In that case, rank of A should always be less than or equal to minimum of m comma n. So, here particularly we are discussing about the matrix of order m by n, which means it is a rectangular matrix, not a square matrix. So, in such cases, what is the rank of A must be? It must be less than or equal to minimum of m comma n. That is the property. Next property. So, if A is a null matrix, you all know what is meant by null matrix, isn't it? All the elements of A must be zeros. For that kind of matrix, what will be the rank is? In such case, the rank of that matrix will be equal to 0. Since, why so? Here you can see the reason, since all minors of order A are vanishes. So, that is what we call the rank of a null matrix is equal to 0. So, now come to the square matrix. So, previously the third property representing the rank of the matrix, which kind of matrix it is? It is a rectangular matrix. Now, we are moving to a square matrix. That is the fifth property you can see. So, if we consider A, which is a square matrix of order n, then what is the rank of that matrix will be equal to? That is, row of A must be less than or equal to n. That is, either it must be equal to n or less than n. And next property, if A is a singular matrix of order n, what is meant by singular matrix is, whenever the determinant of A is equal to 0, we call that matrix is singular matrix. For that kind of matrices, what is the rank must be equal to? That is, row of A should be less than n. Why? Means, if you consider a square matrix or A matrix whose determinant is equal to 0, so definitely the rank should not be equal to n. So, that hence we can say that that rank must be always less than n. Now, if it is a non-singular matrix, so what meant by non-singular matrix? So, just opposite of singular matrix it is. When we call it as non-singular, whenever the determinant of the matrix is not equal to 0. So, hence we are getting a minor which is not equal to 0. What is its order? Suppose let us take the order, it should be equal to n, and we are getting a minor of order n which is not equal to 0. So, hence we can say that the rank of that matrix must be equal to n. So, here you can see the two kinds of matrix, one is singular and non-singular, which is of order n. If it is singular, means the rank must be less than n, and if it is non-singular, the rank must be equal to n. So now let's move to the topic called echelon form of a matrix. So before starting what is meant by an echelon form, so what is the use of echelon form of a matrix means mostly we will calculate the rank using echelon form. So if you see the definition, so which satisfies the two conditions, it is very difficult to find in that way if the order of the matrix is of higher order. So hence in such cases to find the rank is becoming difficult. So hence to overcome there are the methods to find the rank of the matrix. So this is one of that method which we call it as echelon form. So hence by using echelon form we can find out the rank of the matrix easily. So let's see first what is meant by echelon form is. So in order to know what is meant by echelon form, first you need to get what is meant by zero row and non-zero row. So the name itself indicating that one is a zero row, that is the row contains zeros, the other is non-zero row, the row which does not contain zeros. But specifically when we say that row as a zero row means if all the elements of that row of a matrix are zeros means then we call it as zero row. And if there exists at least one non-zero element in a row means we call that matrix is a non-zero row. I repeat, if the row consists all the elements which are zeros, we call it as a zero row. And if the row contains at least one non-zero element, then we call that row is a non-zero row. Those by taking this into the consideration, now let us define what is meant by echelon form of a matrix. So we say that the matrix should be in echelon form if it is satisfying the following properties. What are the properties? The first property is zero rows if any are below any non-zero row. So if you can see the example and can understand what this property. If you are finding any zero row in the matrix, that must be below the non-zero row. That is the first condition. The second condition, the number of zeros before first non-zero element in the row is less than number of zeros in the next row. You can see the example and can understand the second property. So here you are getting 3 rows, right? So in the first row, you can see here this representing the first non-zero element. Before that, how many zeros are there? There are no zeros, which are 0 rows. And if you see the second row, what is the first non-zero element? This is 2. Before that, how many zeros are there? 1 0. And in the third row, this is a non-zero element. Before how many zeros are there? 2 zeros. Now you can see the number of zeros before the first non-zero element in a row is less than the number of such zeros in the next row. Means if you see the first row there are no zeros. But if you see the next zero, zeros are increasing to 1. If you go to the next row, zeros are increasing to 2. This gives the second property. Once the matrix satisfying these two properties, we call that matrix should be in echelon form. So what is the first property is, if there are any 0 rows, that must be below the non-zero row. And the second one is, if you can see the number of zeros before the first non-zero element in row is less than number of such zeros in the next row. If satisfies these 3 conditions, then we say that the matrix is in echelon form. So now by using this echelon form, how to find the rank of the matrix? So this is the point which you have to be noted. In order to get the rank of the matrix using echelon form, this must be satisfied. What that is? The number of non-zero rows in a row echelon form of A is called rank of a matrix. So that means in order to find the rank of the matrix using echelon form, what you have to do is, you have to reduce the given matrix into the echelon form, and in that echelon form, the number of non-zero rows need to count, and that count will be equal to rank of the given matrix. Let us proceed to the question. So this is the first question. The question is, you need to reduce the matrix A is equal to 1, minus 7, 3, minus 3, 7, 20, minus 2, 25, 5, minus 2, 4, 7 into echelon form, and hence find its rank. The question is, you need to first reduce the given matrix into an echelon form, and from that you have to find out the rank. As we already discussed, what is the rank using echelon form is? It is nothing but the number of non-zero rows in an echelon form, we call it as the rank. So now our first target is you have to reduce the given matrix into the echelon form. So let us consider the given matrix. What is our given matrix is? A is equal to 1, minus 7, 3, minus 3, 7, 20, minus 2, 25, 5, minus 2, 4, 7. So now need to apply the row operations only in order to reduce this into an echelon form. So here how to do this means, first need to fix the first row first element as the pivot element, which we call it as pivot element. Now with the use of this element, we need to make the down elements as zeros using row operations. Okay. So for that, what the operation we have to use? In order to make this 7 as a 0, what is the operation I have to use here is R2 as R2 minus 7R1. So if we multiply 7 with R1 and if we subtract, then we will get the value will be equal to 0. And in order to make this 5 is equal to 0, what is the row operation we have to use? R3 as R3 minus 5R1. So multiply with 5 and then subtract. R3 minus 5R1. So then you will get this element is equal to 0. So let us see. So the first row will remain as it is. Coming to the second row, this will become 0 obviously. Why so? The operation is R2 minus 7R1. 7 minus 7, which is equal to 0. Next, R2 minus 7R1 we have to do here. R2, that is 20, minus is plus, 7 sevens are 49. So 20 plus 49, which is equal to 69. Again, you need to apply to the entire row the same operation, that is R2 minus 7R1 minus 23 minus 7 into 3, R2, that is minus 2 minus 7 3s are 21, that is equal to minus 23, 25 minus 7 into 3, which is equal to 46, that is the second row. Coming to the R3 operation, do the operation R3 minus 5R1, that is 5 minus 5, which is equal to 0, minus 2, minus into minus is plus, 7 5s are 35, which is equal to 33, 4 into minus 5, that is 20 minus 3, which is minus 11, 7 minus 5 into 3, minus into minus is plus, 15 plus 7 is equal to 22. So hence by using this pivot element, you are able to make these two elements as zeros. Now what will be the next step? Next is you need to fix second row second element and need to make down element as zeros using row operation. So the same matrix again I have taken in this slide. Now in order to make the down element as 0, before that in order to make this as the simple matrix, we have used these operations. So here in the unit R row, that is R2 row, if you divide with 23, the row will become simple. Similarly for R3, if you do divided by 11, so that the calculation will become easy. So hence I have used this operation, that is R2 by 23, 0, 69 by 23, minus 23 by 23, 46 by 23, 3 minus 1, 2, and R3 by 11, 0 by 11, 0, 33 by 11, 3, minus 11 by 11, minus 1, 22 by 11, which is 2, right? So now this is the pivot element now. Now need to make the down element as 0 using row operation. Now what is the operation I have to use here? R3 as R3 minus R2. Since both the elements are same, if you subtract, then you will get the value is equal to 0 here. So hence apply R3 as R3 minus R2. 0 minus 0, 0, 3 minus 3 is 0, minus 1 minus of minus 1, that is minus 1 plus 1, which is equal to 0, 2 minus 2, which is equal to 0. Okay. So now there are no other things to do further, and now it is in echelon form. Why so? Since we are getting 0 row below the non-zero row, and you can see the zeros are also increasing by the increase of row number. So hence we call this matrix is in echelon form. Finally, you have to decide what is the rank of the matrix. So what is the rank of the matrix using echelon form is? It is nothing but the number of non-zero rows in an echelon form. So if you say this matrix, how many non-zero rows are there? 1 and 2. So hence, and this echelon form has 2 non-zero rows, therefore the rank of the matrix is equal to 2. These are the practice questions. You can take this as practice in order to find the rank of the matrix using echelon form. So hence in this lecture, what we have covered is, first we got an idea what is meant by rank of a matrix, and secondly we got an idea how to find the rank of the matrix using echelon. Thank you.